Okay, so we're still working on integration here and areas, but this time we're working on the area between two curves. In previous videos, we've done things where you've got, oops, try that again. In previous videos, we've done things where you've got an x and a y axis here. You've got a function, maybe like this, and you needed to find the area between the x-axis and the curve. In this one though, we've got two functions and we're finding the area between the two functions. Now there's going to be three cases that you're going to run into. There might be more, but there's three basic cases. The first case is this case here, where you have a function. Let's call the yellow function f of x, and another function, the purple function, we'll call g of x. And you might get asked to find the area between the two functions for a certain domain. So you might get asked for the integral, or the area under the curve between x equals 5, let's call that 5, and x equals 1. So you might get asked to find that area under the curve there. Second case. You might get a case here where they're both below the x-axis. So you can see we were both above the x-axis here. You might get a case here where they're both below the x-axis. And again, you might get asked to find the area between the two curves, there and there. Now again, the yellow one, and there's good reason for this, I'm going to call the yellow one f of x, and I'm going to call the purple one g of x. Finally, there's a third case you might run into, this one here. In this case, let's say you were asked to find the area between here and here. You can see that part of the area falls below that curve, the x-axis, and part of that area falls above the x-axis. Again, I'm going to call that f of x and g of x. Really cool thing happens here. If you want to find the area between two functions, or the area between those two functions at any point, it's very, very simple. For each of these three cases, the rule is this. To find the area here, here, and here, that's 1 and that's 5 again, remember? That's 1 and that's 5. We find the integral between 5 and 1 of f of x minus g of x. So we find the whole integral of that. So we take whatever f of x is, it looks like a cubic or something. We take the cubic, we subtract this, which looks like some sort of quartic maybe. We subtract one from the other, and whatever that result is, we find the integral of it. That's really all there is to this kind of a question. And it's the same for each case. Now, which one do I call f of x? Which one do I call g of x? Whichever one's on the top. So you can see in each case my yellow one is on the top here. So I'm going to call that f of x, and that one's going to be the first one. And then I'm going to use g of x here. F of x, g of x, f of x, g of x, f of x, g of x. Now, there is a way around this. If you don't want to be bothered remembering to put f of x on the top and g of x on the bottom, you can just throw some, you can be lazy and throw some absolute values around either side. Because if you get it backwards, if you get g of x minus f of x, the only thing it's going to change, is that your area is going to be negative instead of positive. So it's not going to be that big a deal. Okay, we might do a question like this so you can see what it looks like first of all. Okay, so I'm going to find the area between f of x, g of x, x equals 2, and x equals 4. Now, what does that look like? Well, first of all, we need to know what f of x and g of x are. Now, I've drawn this in GeoGebra. I'm going to make f of x 2x plus 1, and I'm going to make g of x x squared minus 6x plus 9. So your question will obviously provide this for you. So f of x equals 2x plus 1. and g of x equals x squared minus 6x plus 9. And this is where we're at. And we want to know it between x equals 2 and x equals 4. I'll just draw in some lines here. X equals 2 and x equals 4. This area in here, this is what we want to find, this area. Now, the way that we do that, I'll show you graphically before I start actually doing the maths. What we do is create a new function, which I guess I'll call I of x. And I of x is simply one of these functions minus the other one of those functions. So I of x equals f of x minus g of x. You'll recall this from our last picture here, where when we find the integral, we find the integral of f of x minus g of x. I'm just doing this step now and calling it I of x. So f of x is going to be 2x plus 1, and I'm going to subtract all of that, x squared minus 6x plus 9. So 2x plus 1 minus x squared, so I get a negative x squared. 2x minus 6x, that's going to be 2x plus 6x, so plus 8x. And positive 1 minus 9, it's going to be minus 8. So my new function, I of x, is negative x squared plus 8x minus 8. Now, I wonder what that looks like. Let's take a look. Okay, so I said I of x equals negative x squared plus 8x minus 8. Let's go over to GeoGebra now. Remember that we're trying to find the area enclosed by this curve, and these two lines. So it's the area from this line, that curve, and up to that curve. So it doesn't include this bit and this bit. Okay, let's look at what I of x looks like. So you can see I of x is inverted here. And if we find the integral of I of x between 4 and 2, we'll be finding this area from the orange bit down, which is actually equal to this area around these black lines. It's pretty cool. Oops, that's just moved a little bit. Just get rid of that. So it's pretty cool, and it allows an easy way to find this area just by finding the much easier thing, the integral of the area between the x-axis and that curve. Okay, so now that I know what f of x minus g of x is, if I want to find the area between 4 and 2, all I need to do is the integral between 4 and 2 of negative x squared plus 8x minus 8. Alright, I might knock that one out really quickly. You guys don't need to see me do that. Okay, a little bit of work off camera there, but you guys have integrated before, so you don't need to see all that. Boom, 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 boom. The answer is 40 over 3, so approximately 13.33. I'll show you what it looks like on GeoGebra so you can see that I'm not lying about all of this. Remember what we were looking for again. Let's get rid of that orange line. We were looking for this area in here. That was f of x, that was g of x, and we're looking for the area between 4 and 2. So we're looking for this area in here. Now, let's take a look at what it looks like. There it is. You can see that the area between those two functions and those two lines is 13.33. Now, the way that we figured it out was to come up with a third function, I of x, which was f of x minus g of x. Remember, this orange function here. Now, I want to hide that. What we then found was, we forgot all of this stuff existed, and we instead found the area between 4 and 2 under this curve and between the x-axis. And if you look at it, boom, you can see that that area also, through the magic of integration, is 13.33. This, without this curve, oops, get rid of it. This area is the same as really messing with me. Is the same as this area here. Hopefully I've thrown a bit of light on it. as usual with these things, you're really going to have to get stuck in and start looking at them, start thinking about them. There are a whole bunch of special cases. Let's take a look at just one, just so you get an idea of what I'm talking about. One particular special case that you might be interested in, we've got one function that looks something like this. We've got another function that looks something like this. And you might get asked to find the area between the curves from this point to this point. Now that means you're going to need to find this, this, and this. Now in order for you to do that, let's call this value, this distance I guess, let's just call that -5 there. This point here, let's call that -3. This point here we'll call 2. And this point here we'll call, I don't know, 4. Now in order for you to do that, if this is f of x and this is g of x, you'd have to find this part first, so the bit between 4 and 2. This is the top function, so you'd have to do f of x minus g of x. That was the I of x I found earlier. Then you'd have to, so that's found this area. Then you'd have to integrate between 2 and -3. But you'll notice that in this part, the yellow function's on top. That's g of x. So this part's going to be g of x minus f of x. That finds that area there. And then a third bit between here and here, -3 to -5. And we've returned to the red function being on top, so you'd have to do f of x minus g of x. A little bit away from that, and not only that, but you can probably avoid doing f of x minus g of x minus f of x if you muck around with a whole bunch of absolute value stuff. You can see that there's a lot here. They're very, very basic beginnings, something like that, until we get to very, very complex stuff like the one I just showed you. But it really is all about practicing these things, playing with them, getting them wrong, and then figuring out why you got them wrong and getting them right. So this entire thing, it started all the way back here somewhere. Started all the way back there somewhere. We're finding the area between two curves.